just because we're moving on to the actual portion of today's stream. If it would load. Oh no. Right? And we're pulling it up. And we're done. And we're hopping onto it, hoping it works. And yeah, so again, I'm just gonna drink water. Reminder to stay hydrated, to stay cool, to stay on top of things. Because water is nice. And one thing I'm gonna do is I'm gonna turn on in-game overlay, just because I want to make sure that everything's working. Right. So we'll hop right onto main. And oh, I thought I had it set up already. That's unfortunate. Do I have it up? Oh no, I don't. What? That's weird. Here. Let's go back to chatting for a second. Yeah, that's really. Oh, is that why? Uh, Here, let's try it once more. Is this working? It doesn't seem like it is. Yeah, it's not working. That's really unfortunate. Here, I guess I'm gonna have to just go back to what I was doing. I do have it up, however, I can't really draw well on it. So here, let me try to pull it up. Right. So we're gonna, all right, I probably should have said this earlier. However, what we're gonna be doing today is we're gonna be doing the math portion of SAT. So here, let me just change the title. Does the Okay, so sorry, I'm just updating the title and done. So this is it. I just wish there was some sort of here. I'm gonna try once more. So sorry, give me a second. I'll hop right back on. Here, I'm trying to see if there's a way that I can draw or edit this page, but it doesn't seem like there is, which is really unfortunate. Pen? Does that work? No. Right. Is that working? Here, sorry, just give me one more second. Well, not one more second, but pen. I'm just looking up view pen and touch info. Device rename. Right, this should not take much longer. I just want to see if I can get it to work. Here. I keep saying sorry and whatnot, so let me just mute my mic and I'll hop back on in a second. All right, I have good news and, well, bad news. Good news is I think I can get it to work. Here, bad news is I'm gonna have to use full screen screen. Oh, entire screen monitor one. Next, done. All right, so I think I can get it to work. Here, let's see if I'll just hop them in for a second. Yep, we got that infinite repeaty thingama what's it, hoopita bop bop. All right, so what I'm gonna use, I'm actually gonna use a second application called Paint to well, do my drawing and whatnot. Just because I can't get like a pen to work. So I guess without further ado, allow me to um, make sure everything's working. And yeah, so we'll hop right into it. And we'll put paint up for now. Actually, we're not. We're going to put paint away. All right, these are the answers. So I didn't look at the answers. I do have them up just to make sure that I'm not dead wrong. So, you know, well, it goes. That's what they say. But yeah, I do have the answers pulled up just for the math portion, I suppose. Here, actually, I need to go to the correct page for it. Page 26, which is right here. Perfect. So for questions 1 to 15, choose the best answer. Actually, what I'm going to do, 2-page view. And this would let me, well, here's the paint application that I'm going to use. Here, let me adjust it so it fits in the correct page. This will let me show you my process and how I think and whatnot, what the answer is. Perfect. Wait, sorry, give me 1 second. I think I have an idea. I'm just changing my settings. I'm enabling hotkeys again. I didn't do it last time because it's really been throwing me off. However, I think I got it set. Right, and this should be good. I hope. I'm gonna give it 1 second. Wait, actually, you know, I just need to check that everything else is working. Right, here, let me just mess with it for a sec. So yeah, it does seem to be working, and I'll hop back on. Yep, all my hotkeys seem to be working. That's good. I just want to make sure they work because I have had problems with them the past few days, and I do apologize for that. However, we can resume. All right, I'm just making sure this works, and I hope it does. Right, so math test, no calculator, 25 minutes, 20 questions. All right, we're not gonna use time limit because this is just practice and me teaching. So yeah, I do hope. Right. So without further ado, let's read it. Directions for questions 1 to 15. Solve each problem. Choose between the best answer from the choices provided and fill in the corresponding circle on your answer sheet. For questions 16 to 20, solve the problem and enter your answer in the grid on the answer sheet. Please refer to the directions before question 16 on how to enter your answers in the grid. You may use any available space in your text bullet or scratchbook. Note: the use of a calculator is not permitted, so we will not be using a calculator for this. 2. All variables and expressions used represent real numbers unless otherwise indicated. 3. Figures provided in this test are drawn to scale unless otherwise indicated. 4. All figures lie in a plane unless otherwise indicated. And 5. Unless otherwise indicated, the domain of a given function f is the set of all real numbers x for which f of x is a real number. All right. What that means, that's just all textbook math jargon and whatnot. It means that you can't use like complex math magic, black math magic, or whatever you want to call it, that makes it so that your answer technically isn't correct. You know, like those proofs where 1 is equal to 2. Well, that's a bit of an overstatement, but yeah, that's it. That's all it's trying to say. And we have a nice, neat little reference for all your areas and whatnot, specialized triangles, volume, which we might refer to, hopefully not. But yeah, question 1. Yeah, so we do have question 1 right there, and we'll move this aside. If x minus 1 is equal to 3 and k is equal to 3, what is the value of x? All right, so we have x minus 1, and yep, this is going to look terrible. So 1 over 3 is equal to, well, let's just write equal to k, which is equal to 3, which we wrote. So we can just get rid of k entirely. So here, actually, let's just do that. I haven't actually used paint, so, oh, that was supposed to, yeah, I don't know what I'm doing, honestly. Is there an eraser? There is. I can't do that. That's unfortunate. All right, so maybe I should focus more so on maybe a little bit wider. Oh no, undo that. Actually, I could just undo a lot of this mess. So we'll write k is equal to, well, k is equal to 3. What the? What am I even doing? This is strange. 3. Right. Yeah, and this is going on. So we'll multiply by 3 on both sides. So we'll get x minus 1 is equal to 9. Or x, add 1 is equal to 10. And I believe that should be the correct answer. Let's make sure I didn't do anything wrong. And yes, that should be choice D. I will double check though. 1D is correct. Yes. Here, is there a way I can clear this? File, clear. Man, this is actually a bit strange. I very, paint. Oh, no, no, no. Control Z. Paint. And there's still brush marks, so I'm just gonna do file, new. Don't save. Yeah, that might be easier. Is there a way to change the thickness of this? Of size, yeah. That will be better. All right, so move on to, so we have 1 is D, and that is correct. Unfortunately, I can't mark it on the paper, but we know 1 is D. All right, so for I is equal to -1, what is the sum 7 plus 3i plus, parentheses, -8 plus 9i? Now, this is actually pretty easy to visualize, but let me just say, that's a very poorly drawn I. So let me just clear that first. Oh no, I'm gonna have to click on everything to clear it, won't I? That's unfortunate. Keep forgetting, my bad. I is equal to square root of -1. That is true. However, for this problem, it's equal to x. Why? Because x is a variable we're more familiar with as a people, and I being equal to the square root of -1 does not matter at all in the slightest in this problem. And let me rewrite this. So instead of this, we'll do 7 plus 3x, and then to that we're going to add, and we're going to add on top just to make it hopefully a bit easier to read, -8 plus 9i, or 9x, I suppose. And we're actually going to split this in the middle because there's no way the x is going to come over to the ones, just the regular ones, the no coefficient, and vice versa. That's not going to happen. So we'll add 7 and -8 to get -1, and we'll get 3 and 9 to get 12. And first of all, we're going to add the add back in because, well, it's adding both. And we're going to bring the x down. However, we're going to change it back to an I because that's our answer. Yep, this is our answer. -1 plus 12i. So A is the correct answer for part 2, or question 2, and that is correct. All right, now let's hope that this works. No, it doesn't. That's really unfortunate. And there's no way I can just brushes. No. This is view. Home, image, clipboard, Can I'm sorry, I'm not familiar with this, so I'm not doing well. But I just want to clear the screen. File, I guess just new, don't save. Right, moving on to 3. On a Saturday afternoon, Armin sent M number of text messages. So we will just write M is equal to text messages. Text. Right. So M is equal to text. Armin's text messages in particular. So for 5 hours, and Tyrone sent P text messages each hour for 4 hours. So, sorry, it's not text, it's text per hour. HR and P is equal to the same thing, so we'll just write that. Granted, it's a bit messy, bit whatever, bit hullabaloo, mumbo jumbo, all that jazz. All right. So that's not the point. What's the point is the following represents the total number of messages sent by Armin and Tyrone each Sunday afternoon. So the total number, let's call that N, is equal to the hours times the rates. HR times rates. So for Armin, he sent N text N text per hour for 5 hours. And for Tyrone, he sent P text in P text per hour in 4 hours. So 5M and 4P. Right. However, the rate is the total. It's asking for the combined for on Saturday afternoon, and yeah, it's Saturday. So it's combined, so we do have to sum them, and we'll bring that around and down. 5M plus 4P. And that is our answer, 5M plus 4P. And that should be the correct answer, so that should be C. Oh, we want question 3 first. Yep, C is correct. All right, and we're gonna do file new because I don't know how else to clear the page with relative ease. For Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need to. You know what? Sorry, something's been bugging me. I just can't zoom in on the problem, so I'm just gonna switch back to annotations. Oh no, that's better. That's much better. Never mind. I'm just a bit foolish, and that actually makes it a lot easier for this. Repair technicians for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has, the number of phones that she has left to fix at the end of each day can be estimated with the equation P is equal to 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value of 108 in this equation? Right. So this is a meaning question, which means you just have to find what that means. So P is the number of phones left. All right. So it looks like it's starting at 108 and going down, in which case 108 would in fact be not the repairs phones at a rate of 108 hours per day. So we can eliminate C and D because we already know the rate at which they repair phones per day is 23 because of this part, minus 23D, where D is the number of days she has worked that week. So the rate would have to be multiplied by the number of days she's worked that week, which would be multiplied by 23. So we can eliminate both C and D. And now we have to determine, is it days or repairs? However, P is in terms of repairs, and 108 is not multiplied by anything else. So we can conclude that the answer for 4 is, in fact, choice B. Why? Again, so let's go through everything. For A, complete the repairs within 108 days. Well, P is in terms of phones left. So if it were in days, there's nothing to convert days into phones left, or phones in general. So there's no conversion, which eliminates A. B is just from that, it's technically correct. We might be able to nitpick it here and there, but let's move on before we actually try to judge that. C repairs phones at a rate of 100 hours per day. Again, and D repairs phones at a rate of 108 per day. Both those are rates. Both those are more complex. They're phones per something. That's a rate. And what P is just a number of phones. So for a rate to be converted to something else, it's units. That's really what they're asking for here. Considering, we must know that 108, considering it stands alone, it is not multiplied by anything whatsoever. And considering that P is in fact in the number of phones left, we can conclude that 108 is in fact phones. In terms of phones, which eliminates A, C, and D. So B is the correct answer. However, assuming, let's say this problem was a bit harder, and instead starts each week with 100 phones to fix, or let's say it was instead starts off each week by fixing 108 phones, we'd have to dig into it a bit more. And based on, I guess, logic, I'd say, let's assume D is 0. They have worked, Kathy has worked 0 days, which is P is equal to 108. However, Kathy has work to do on those phones. So by that logic, we can conclude that considering P is the number of phones left, and if Kathy has worked 0 days, P is equal to 108, and 108 would then equal the number of phones left, and Kathy has done 0 work on the phones, we can assume that 108 is the phones to start at each week to fix. So B, which either way you want to tackle it, is correct, and we'll move on to 5. And we didn't even have to do any actual drawing. It was just thinking with our brains, and that's really nice. Right. Which of the following is equivalent to the expression above? And we have this a bunch of jargon and whatnot. So yeah, I'm gonna have to write this all out. And luckily for me, that they're all in some sort of form. Well, actually, before that, actually, I'm not gonna say that before that. But let's write them as we did earlier on top of each other. So we have x squared y. And notice the power of x. We're going to use that as a main indicator for everything. And the power of y is 1. So I was going to put the power of y to 1, but we're not going to do that just because y on its own is very easy to see. But if you feel more comfortable doing that, go ahead. Feel free. 3y squared plus 5xy. 5xy. Sorry, 5xy squared. Now, you know what? I'm actually gonna, am I gonna change it? I don't know. You know what? I won't change it. However, I will rewrite the bottom equation. And I will actually distribute the negative as well. So I'm gonna make it plus actually instead of minus. So what I'm doing in this bottom equation is, sorry, for the second part over here, right here, is first, here, let me pull this up. Actually, yeah, I just have to click it. First, what I'm going to do is I'm going to distribute the negative to each individual term. And secondly, I'm going to swap the positions of, well, the 3xy squared and then minus 3y squared. Right, and I'll do that immediately. But first, we have plus x squared y, x squared y. It's here. I'm going to divide these in such a way that we can easily see them, well, better. Just because we should expect a 3-term answer based on this. Based on the fact that all the coefficients, blah, 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 are the same, which I'll finish writing in just a bit, we should, so far at the very least, expect a 3-term answer, which would put D in the lead. However, we need to prove it's a 3-term answer, which, spoiler alert, just a wee bit, we know it is not actually a 3-term answer. But we'll get to that when we get to that. Just by looking at something, we know that, but we'll get to that in a second. Right. So I'm going to put the negative 3y squared second, and I'm going to distribute the negative to make plus 3y squared. And actually, what I'm going to do now is I'm going to start actually adding the first two terms. So we have 2x squared y, which eliminates, and considering nothing else affects the 2x squared y, we can eliminate a and b so far. Because, well, actually, let's start. We can eliminate a because there's no x squared y squared term in this equation. Because, x squared y squared, you know what? I'm sorry, I'm getting very far ahead of myself, and I do apologize. I need to stay on one motion, one constant motion. For this, we get plus 0. We could put y squared, but we don't need to because it's a negative 3y and a positive 3y, so they cancel out, right? Now we're on the last term, minus 3xy squared, because we distribute the negative, so you get minus 3xy squared, and that'll get us plus 2xy squared. And that leaves us with choice C, which should be the correct answer, and it is. And so, yeah, we have, I guess I'll circle everything I can. I'll not include the 0 just because there's no reason to, but yeah, that's our answer. 2x squared y plus 2xy squared. One thing to note is that what the test takers can do, because they're evil people who are bad and mean, is that they could instead, let's just, like what they did actually that was pretty mean was they swapped the position of, what I did, I swapped the position of these two because I wanted to line them up with their coefficients, y squared and xy squared. They swapped that, and that's pretty mean. What another thing could be mean is instead of having y squared, they could have had just y. And what that would mean is it would be 2x squared plus 5xy squared minus 3xy. That would be them being mean. So I'm glad they didn't do that, but they still aren't the nicest people around just to give those sort of problems. And for future, you do need to pay attention to those sorts of things and look out. However, that's not our problem because it was, well, correct. Right. We're on question number 6, and we are going really slow. I'm trying my best to explain it, so I do hope it's coming across, well explained, but I can't necessarily prove that and whatnot. Right. Question number 6, we have the equation up top. H is equal to 3a plus 28.6. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Now, you'll notice one thing I didn't do at the start is rewrite this equation over here. And that's because until we actually need to do so, why would I spend time writing things down when I can just look at the problem and, well, get it? Now, based on the model, what is the estimated increase in inches of a boy's height each year? Now, one thing I can pull out from that, without looking at the equation or anything in particular, is that they're looking for a rate. They're looking for inches per year. Considering h is in inches and a is in years, we can assume that the 3 times a is something that's in terms of inches per year, because inches per years times years equals inches. So we can assume that for 6, the answer is indeed A, and that is the correct answer. And looking at the problem and the other choices, you might think it's strange that it doesn't have a decimal or anything, that it's just 3 on its lonesome, and also that it's the lowest value. You might look at 5.7, 9.5, and 14.3 and really be concerned about the complexity of this problem. But don't worry, college test takers are just really mean people who don't like you. It's not that it's hard, it's just that they're rude and mean. Okay? Remember, it's never your fault, it's always the test maker's fault. Or something like that. These test makers they do their best to make you do bad. which is a big argument against standardized testing and whatnot. So yeah, just remember, do the best that you can. A lot of these problems are more simple than you can realize because these test makers really like to make easy problems hard and hard problems impossible. But yeah, so don't get overwhelmed by looking at the answers. Oh, and also a good test taking strategy to do is solve the problem before looking at the answers. You use the answers to check that your solution is correct. For instance, let's say I did some math on this problem and thought the answer was, well, oh wait, I'm on the wrong thing. Let's say I thought the answer was 4 on this problem. Then I go back and check, and I see 4 is not an option. Then I know that 4 is not, in fact, the answer, or at least for the problem. Granted, there's always a possibility that test makers can be wrong. There is a possibility. However, you should always assume that you're wrong. Why? Because there's a lot of, in spite of the fact that test people makers are evil people, they can be pretty smart. I will give that to them. They're clever. They're not good people, but they're clever. Though I'm insulting test makers a lot, I will say not all test makers are bad. I really appreciate teachers who do make their own tests, especially those who do it in a way that's fun, exciting, and tailored to a student's learning experience. Furthermore, I also really do appreciate the people over at Jeopardy who make the questions and like Who Wants to Be a Millionaire. All those talented shows, really impressive. However, standardized testing is the devil's work and it's awful. Uh, you know, um, a bit of a break between this. If you're watching this on Twitch, please follow. If you're watching this on YouTube, which I'll post later, or I have posted later, uh, please, I guess, like and subscribe. Maybe tell me in the comments something that you want me to go over more in more detail, because I'm not super smart in math. However, I'm at a student's level, so I understand. I feel better than some people how students react to certain problems and whatnot. So yeah, if you want, please don't forget to feel free to chat in the chat or leave a comment on the YouTube video asking me to go over something else because I'm more than happy to do that because this is just for fun. I'm just doing this for fun and for you. So always put value in yourself and whatnot. People are always willing to help you, so don't be afraid to reach out and everything. Right, I'm getting a bit sidetracked. So I jump back into problem 7. In problem 7, just looking at it, it looks really complex just because you have a ton of fractions, some exponents, and a lot of variables. 4 to be exact. You have M, R, N, and P. But you know what? Let's just look through it. The formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. Which of the following gives P in terms of M, R, and N? Oh, all right. So I'll snap back to reality for a second. Okay, so I will say this one thing. I don't want to draw out this problem because, again, with test makers being evil and whatnot, this is actually exceedingly simple once you get into it. So I'll make it really, really simple. I'll make it as simple as I can. So we'll have M, right? All right, we'll use M for this, and I'm making it as simple as possible for 2 reasons. 1, it's easier to visualize, and 2, I don't want to draw this whole thing out. All right, so instead of R is over 1,200. Let's call that rate 1. We'll call that R1, and we'll do 1 plus R over 1,200 to the N, that whole thing to the N. We'll call that R2. R2. And I'm using R1 and R2 just to signify that they are in fact rates. Granted, for a problem like this, maybe to visualize better, you could use X and Y. Those are very nice and dandy things. However, this just really simplifies the problem so much more. Because then we have, instead of that entire jargon of whatnot, we actually just have R1 times R2 over R2 minus 1, R2 minus 1 times P. And I'm actually going to put parentheses on the bottom just because. Right. And now we're trying to get it in terms of P. So we'll multiply by the bottom. Or sorry, we'll cross multiply. I suppose. We'll cross multiply in the right term. But yeah, we'll multiply by the bottom. We'll multiply both sides by R2 minus 1. So we have M R2 minus 1. R2 minus 1 is equal to R1, R2P. R1, R2, and P. And then to get P, we'll divide by R1 and R2. So we'll get P is equal to R2 minus 1, R2 minus 1 over R1, R2 times M. And we'll plug this, and we could just plug everything back in, but that's our answer. But yeah, that's our answer. We'll plug everything back in and whatnot. And we'll get that, in fact, number 7, the answer should be choice B. You know, this whole thing, you know, R2 minus 1 over R1 times R2 times M. Or 1 plus R over 1200 to the power of N minus 1 over R over 1200 times 1 plus R over 1200 to the nth power. Now, substituting that, what I did with the substitution for R1 and R2, I feel it's very useful. I really subconsciously do it when I do problems like these, simply because it makes it so much easier, because there's so much unnecessary jargon and numbers and whatnot that aren't necessary. We don't need R over 1200. We don't need 1 plus R over 1200 to the power of N. In fact, R and N are completely useless in this problem other than placeholders, which is why I said we can use X and Y. However, I did do this problem in a more complex way. One of the easiest things to realize in a problem like this is that basically, instead of M is equal to, actually, we'll rewrite this here. I'll box this off. Instead of using R1 and R2 and minus 1 and all that jargon, we'll just write M is equal to, we'll go X over Y. I was going to write just X and just do X is equal to, and just divide by X on both sides and get M over X is equal, actually, yeah, I'll just do that. M is equal to XP. P is equal to 1 over XM. Actually, you know, I'll do it the other way just because it's easier to see for a problem like this. So for a problem like this, we'll multiply by the bottom and divide by the top for P and to get P alone, and we'll get M. So yeah, a problem like this, you literally just flip the fraction. And again, this goes along my lines of test makers are evil people. But yeah, a problem so simple as that is made complex. Because if you think about it, all this problem boils down to is this. You're really using logic and reason. You're not really using mathematics at all at a high level. If you think about it, an algebra student can do this. And yet you have been in high school for 3 years already. You've gone through all this. You're so well educated at this point. And the test makers are doing their best to make simple math hard. They're doing all this just to hurt you, I suppose, for lack of a better term. And, you know, that's why I boiled down to test makers equal people. But the key to the SAT in general is to make these problems easy. Make them so incredibly easy that it's, well, easy to do it. Right, so that was problem 7. We'll move on to problem 8. But yeah, also this goes to the fact that anyone can do the SAT. You are more than smart enough to do well. Believe in yourself a little bit more often, because, you know, you could look at a problem at problem 7 and get super stressed by it. You could see all these complex numbers. You could see 4 variables. You could see 2 unnecessary variables and then over 1200, all that jazz, and you might freak out just by looking at it. However, if you really just try to break down the problem as simple as it can be, it's going to be very relatively easy. Right, so we have a over b is equal to 2. What is the value of 4b over a? So we have a, all right, sorry, I draw my a's like that with a little bump on top, like when you type them in lowercase a's. However, for this problem, I will do them the normal way just so I don't confuse them with 2, because I sometimes, especially in platforms like this, it's hard to draw and they can get confused. So we have a over b is equal to 2 over, we'll use over 1. We'll basically what we're going to do is we're going to put both sides to the negative first power. Both sides to the negative first power. But, you know, some people might find that complex or hard, all that jargon. So, which is completely understandable. I'm just used to it. So it's easy for me. But, and it is an easy way to write what I'm doing for me because I understand it that way. However, what we're going to do is basically we're going to multiply by b on both sides, divide by a on both sides, and then divide by 2 on both sides. Or really what we're going to do is we're just going to flip both sides around. So we'll get a, sorry, I did it again. Just to do it in a way that it's more easily understandable for everyone, we'll rewrite this as a, oh that's really poorly drawn, is equal to b. Then we'll write this as 1 is equal to 2b over a. Granted, from here we can just go and multiply both sides by 2 and get our answer. To be fair, however, just for the sake of this, we'll get b over a is equal to 1/2, or 1 over 2. Granted, we could just go for, like, I'll put a star here just to show that we could really go on from this step. However, just for the sake of the problem, this is a long way to get where I did. And what I did was just, you know, flip both sides, get b over a is equal to 1/2. Now, another thing to note, this can be, while just flipping something to negative first power can be addicting, easy to use and whatnot, just, you know, deciding to flip it. Please do note that, let's say it's something like 2 minus 1. You can't just, let's say this is negative first power. So yeah, we have this, but I'm just doing this jargon just in case. You can't just do this and say this does not equal 1/2 minus 1 over 1. This is not true, because that would equal negative 1/2. Instead, what it does equal is it equals 1 over 2 minus 1. So do be careful when putting things to negative first power. Using the top way, you will be able to, well, do it safely. But yeah, that's the confusing part about this sometimes. So, or sorry, which equals, I should say, 1/3. Yeah, so please do take caution sometimes, because the smartest of the smart make this mistake more than often. And it's really, really confusing sometimes. Right, so we have b over a is equal to 2, 1/2. So 4 times b over a would be equal to, and I do apologize, my writing is more poor than my brain, but yeah, 4 times 1/2, which is equal to 2. And again, we can just multiply this by 2 on both sides to get 4 times b over a is equal to 2. But yeah, so the answer for 8 is in fact C. So in fact, oh, I actually looked wrong, but yeah. So yeah, do take caution. Again, this is really, I don't actually know. They do rate problems on how easy or hard they are, and I don't know which ones they've rated hard or easy. Maybe if I can pull that up, we'll discuss that afterwards and talk about the hard problems and easy problems. But yeah, and I probably should have researched that more, just because I know people who hard problems people struggle with more, and really simplifying that problem to make it an easy problem would make it much easier to solve. And I do know the time limit can be pressing for some people, and I know we're not following it, but to practice, just get it down how you like to tackle a problem and try your best to do it as quickly as you can. Well, not even as quickly as you can, quickly and correctly as you can. But yeah, that's our answer. It's choice C. Right, now we're on problem 9. What is the solution xy to the system of equations above? All right, so now we have two equations, and we have to find their solution point. Now, there's 3 ways to solve an equation like that. Actually, I'm going to use text. Graphing. Graphing is one solution. I forget all the names of everything, but graphing, like, you'll just graph both lines on a piece of paper and find the intersection point. Right. There's substitution. Let's say, which we might use for this, and there is, I forget what the last one's called. But honestly, it and substitution are very similar, so it's not even that crazy. But, oh man, I do forget what that last one is called. I forget the term. I know how to do it, but I forget the term. Here, let me just describe what it's like. Basically, elimination, that's what it's called. Elimination. All right, now, one thing to note. For this, considering it's no calculator, you will not be able to do graphing. So that's out. And now you're left with substitution and elimination. Personally, I think substitution, I think I like it more. It's actually pretty hard to say which one I do like more. Because they're both actually pretty cool in their own rights. I mean, they're also a bit grindy in their way. So here, let's start off with elimination. Elimination. And I'll do it both ways for the sake of this problem. Pick the way you're most comfortable with. But yeah, graphing is the easiest solution, I feel, because you just plug it into something like Desmos or your calculator, get the answer. If your teacher allows you to use a calculator in test, it's perfect. But for this part of the SAT, we're not allowed to. Though I actually will, just to prove it, like after this, I'll plug it on Desmos and whatnot. But yeah. Here. Also, a thing to note, just by looking at this problem, really the first equation, 3x plus 4y is equal to negative 23. At least one of x and y are negative. Granted, that follows suit with everything else. Oh, sorry, and there's the fourth option that's always possible. Plug and chug. That's what we used to call it in my grade school, and not grade school. Yeah, not grade school, that's my bad. But yeah, that's what we used to call it, plug and chug. Basically, you plug in every answer for x and y, and you see if it works. Now, I will just say that eventually, if you don't know how to tackle a problem, plug and chug is always an honorable method. However, considering there's no math behind it, we won't discuss it, but it always does work. So please take that with a grain of salt. Take me eliminate with a grain of salt. I know how to solve these problems. I do. I really do. So I'm going to use the methods I know how to solve them and use them to solve them. For someone who doesn't know, or someone who just forgets, or someone who's just not getting the right answer, plug and chug always a great solution. Always great. For instance, here, let's just do plug and chug for A. Negative 5, is equal to x, and negative 2 is equal to y. Negative 2 is equal to y. Let's use the bottom equation just because the top one I think it works, the bottom one I know it's wrong. But yeah. 2y minus x is equal to negative 19 is equal to negative 1, 9. Oh yeah, and by the way, again, what I said before about considering based on the top equation, at least one of them has to be negative, we can conclude that if there was an answer where both were positive, we can conclude that that answer is incorrect. Again, technically plug and chug, but without doing the math. So negative 19, I did write that poorly. So 2 times negative 2 minus a negative 5. And if we do this, we get negative 4 plus 5, which is equal to 1, which is not equal to negative 19. Yeah. Basically, you would need to do that. You need to prove basically everything wrong except for the one that's right, and you need to prove that right. So it might take a while and all that jargon, but it's a valiant method. I'm just not using it because I know how to solve this problem properly, whether it's elimination or substitution. But if you feel comfortable doing it that way, go ahead. Especially if you have extra time. If you have extra time, more than go ahead and do that. Furthermore, plug and chug, it can also be used to check your answer, which we will get. Right. So now let's move on to elimination. Elimination is, well, basically that. So we have 3x plus 4y, 4y. And then I'm going to rewrite this so it's minus x plus 2y plus 2y. And it's equal to respective values of negative 23, and equal to negative 19. Right. Now, what I'm going to do is I'm going to multiply each term by negative 2. So basically why I'm doing this is I want to get this y value to equal, actually no, I'm going to multiply by positive 2. And I want to get this y value equal to the y value on top. So we have, so I'm just going to draw a line through this and just rewrite it underneath. Negative 2x, I almost forgot the negative. Don't forget the negatives, please. Plus 4y. 4y is equal to negative 38. And what we're going to want to do is we're going to want to subtract this bottom term from this top term. And I do apologize by drawing is a bit atrocious, but yeah. So we'll do that. And that'll leave us with 5x because it's a 3x minus a negative, so plus 2x. So 5x plus 0. All right, so we got plus 0, and that's good. And then that equals, and then we have a negative 23 minus a negative 38, or a negative 23 plus 38, or really 38 minus 23, which is just 15. And then we have x is equal to 3. X is equal to 3. And that's part of our answer. Right. So technically speaking, we would be done here because the only answer with 3 in it is B. And in fact, B is the correct answer. But 3 is the only possible value for x. However, let's suppose for the sake of argument that there were 2 answers with 3. Let's suppose C was 3 minus 6x, 3 and minus 6x. Let's assume that was it for the case, in which case we need to find y. And now what we would do, technically we could just do this entire elimination process over again, but instead of us doing what we did with y, we'll do it for x and then we'll solve for y. However, that's way too much work and we could just plug and chug, you know? So we'll use the bottom equation for this sake. So we get 2y minus x, or in this case, minus 3, because 3 is x, is equal to negative 19. So we'll add 3 to both sides, is equal to negative 16. And sorry, I forgot the 2y. 2y, and then y is equal to 8. And granted, if you want to check, you can. You always should check your answers. However, your checking was literally just the math you did. You should feel confident that if you get your answer like that, it'll be right. And now, even though we solved the answer, it has to be B. Oh, and furthermore, I would like to say one more thing about this. We know there's only one solution point because they're both linear lines. For linear lines, there is either one solution point, in which case the slopes are not the same. The slope, you know, in the form y is equal to mx plus b, the slopes are not the same. That's one way. That's when there's one intersection. There can be no intersections or infinite intersections. However, that case applies when m is the same, when the slope is the same for both lines. And there's no solutions when they're parallel lines or when they have the same slope but different intercepts. For instance, b is 1 versus b is 20. Those lines will never meet. And when they're the same intercept, there's infinite solutions because they're the same exact line. I feel that I should have said that earlier, and I do apologize. However, just so you know, granted, this problem's not this sort of problem, so we don't really need to consider it so much, but do keep in mind that there are going to be situations where they might have more than one solution. Oh, also, if it's like an x squared, you should assume that there's either two solutions, one solution, or zero solutions when compared to a linear line. 2, 1, or 0. That's what you should assume when compared to a linear line. All right, now we're in the final method, substitution. This was substitution. I think I might have spelled it wrong, but it doesn't matter. Right. So now we're doing substitution, and I think this is the one I use more commonly. Maybe, I don't know. But here, let's take the bottom equation first, just because we have 2y is equal to, 2y minus x is equal to negative 19. Now I'm going to jump a bit ahead. Normally I would show you each line of me adding x to both sides and adding 19 to both sides. However, just because I assume you're all geniuses at this point, and because we thoroughly did this problem already, I'm just going to do it. And I'll bring x over to the right side, basically. I'll flop the equation around, whatnot, blah, blah, blah. X is equal to 2y plus 19 plus 1, 9. And we'll use this as for x. So now we have 3x plus 4y is equal to negative 23. So instead of 3x, we're going to do 3 times 2y plus 19 plus 1, 9, 1, 9, plus 4y. Plus 4y is equal to negative 23. 23. I didn't draw the equal sign properly. And basically now what we're going to do is we're going to multiply this term, the 3, by the 2y plus 19, and then add the 4y, and we'll simplify it basically. But yeah, that's why it's called substitution. So basically find x in terms of y and plug in x in the other equation. And well, that's why it's substitution. Right, so we get 6y plus 4y is 10y. 10y plus 19 times 3, that should be roughly about 57. 57 is equal to negative 23. And then we'll subtract 27 from both sides and divide by 10, just because we can. Y will be equal to 8. And then we would, again, plug and chug. Like we could do, again, the opposite thing for x, but we're not going to do that. We're not savages. We're geniuses. So we're just going to plug in y into either equation, because either equation will give us the value of x. And I'm not going to do the math here because we've done this problem so much. It's kind of overdone. But we can, in fact, conclude that x would, in fact, not 8, negative 8. I do apologize for that, and I didn't even draw it there. My silly bad. Oh, never forget your signs. Smartest person will forget their signs, and you can do better than them, despite not forgetting. But x would be equal to 3. Right. I'm going to take a quick 1-minute break just to get my water, get some more water, use the bathroom, all that jazz, because my throat is getting hoarse. So just a bit. Oh, sorry. I'm just going to go on chatting, and I'm going to mute. I'll be back in a few. And we are back. Just give me a second to load everything up, and that should do it. Oh wait, I just need to set a new file and don't save. Right. All right, so we just did problem 9 in the longest way possible and got it down to choice B. Oh, and now we're in problem 10. Right, problem 10. G of x, or G of x is just, for those of you who don't know or aren't familiar or just are scared by it, it's just saying y. G of x is just a function, you plug x in, you get out a different variable. It's the same as saying y of y is equal to. But yeah, and same as equal, f is equal to. But g of x is equal to a times x squared plus 24. For the function g defined above, a is constant, and g of 4 is equal to 8. What is the value of g is equal to negative 4? All right, so this shouldn't be too hard. So we have g of x. So what we're going to do first, here, let's actually write this down. So considering we have a lot of things, what we're going to do, one, solve for a. Solve for a using given. We were given a value g of x and the value x such that the statement is true, and there should only be one a where that statement is true. Should only be one a. Ooh, wait a minute. Can there be two a? Is that possible? Oh no, there's not. For this, it's not necessarily possible for that. Here, I will say why. Technically, it can be possible. And sorry, to plug in a and solve for g. And that's their solution. Sorry, I did two wrong. So one, we're going to solve for a using the given, or the g of 4 is equal to 8. And two, we're going to plug in a, I'll make a capitalized, and solve for g. We will solve for its value in the previous step, so we'll plug it in. We'll plug in a negative 4 for x, and then we should be left with the g value. Now, what I was saying before about there possibly being two solutions is technically possible. A could either be positive or negative. That is most certainly true. However, we do know that a is negative. And you might be asking, how do we know this? Well, let's assume a is 0. That would mean 24 is the value of g. But a being anything greater than 0 shows that the minimum value of g would be when x is 0, or at g of x, when x is 0, or 24. So basically, I'll just draw it on a little bit like this, on a graph like this. So let's say, this is when a is equal to 0, and then graphs like this, a greater than 0, and graphs like this, a less than 0, a less than 0, right? And there's some value like around here. And a can be bigger or smaller. So we know a is negative because it must be less than 24. And a can be bigger, like this, or smaller. Or sorry, a can be, let's say a is smaller. So a is just, let's say 1/2. It'll be a longer, just because it takes more to change the function. And if a is bigger, let's say 200, it'll be more like the inner graph. Like it's very fast changing. Right. But we do know that a has to be less than 0. So we can eliminate choice A, we can eliminate choice B. Again, you could also eliminate them by plugging them in and testing them, but yeah. So that leaves us with a -1 or -8. Oh, wait. And now we're using the value of g is equal to -4. So I was actually going to say that we could just plug them in and find an answer. And we can do that, but I was assuming that I was being foolish in assuming that, because I assumed that we actually knew g of -4 was, but that's what we're solving for. So I was foolish. I was thinking about what a was, not what the function is in its own right. But yeah, we could plug them into g of 4 is equal to -8. sorry. And so considering we eliminate, sorry, I'm getting off topic here. Let me just write a considering statement. Considering we eliminated two values, we could plug and chug. We could plug and chug. And that would be efficient. And that would be efficient. That would be efficient. You could just plug it in. You could just really just throw it all in there, and you would get. Wait, did I do it wrong? Oh, oh wait, nope, that's my bad. I really did mess up. Again, I assumed that. Oh man, I'm sorry. I was really foolish about that. Control Z, Control Z, Control Z. Sorry, I was being foolish. I assumed that the answer choices were A again, in spite of the fact that I really determined that not is not the case. However, I will just say that A is negative. That's all we have. Sorry, I was being foolish and got caught up in my own head. Really apologetic about that. Right. Sorry, I was trying to skip steps that we weren't able to skip. Let's just go off of our original formula. So we have g of x is equal to ax squared plus 24. So we have g of 4 is equal to 8. So g of 4 is equal to 8. Oh, wait. Sorry, I was being foolish. The answer is 8, A. A is the correct answer. I was going to say that we were going to do the math, we're going to do that. However, and this is the thing, there are always some sort of shortcuts in these problems, and it took me a little bit too long to recognize this. However, I will just state this. A parabolic function is symmetrical. Oh. A parabolic function is symmetrical. Bam, bam, bam. You know, we have to throw in the exclamation points just to show how symmetrical it can be. That means it's mirrored. It is mirrored across the y-axis. So it doesn't even matter what A is, considering it is mirrored. Granted, there are other situations, for instance, here, yeah, I was saying, for instance, let's assume the case, oh, I just drew that poorly. Like when a pair, yeah, so if we drew this, and I even drew it over here, it perfectly, like its minimum point will be at 0, or maximum point will be at 0, because at 0, that is 24. There are other functions that are a bit different, such as, let's assume ax plus b, say ax squared plus bx plus c, the constant. This is a bit more like, here, let's just, for example, show you, this is a bit more like this, where this is c. Yeah. So I do apologize. That's a notable exception. Wait, no, C is not. C is not the minimum or maximum value because of B, in fact. B just throws it off just a bit. So yeah, there are functions like that. However, there is no B of x. And B of x affects, you know, when x changes, G changes. So yeah. But considering B of x is the only thing that will make it not mirrored. So we're going to do what we did before, or we talked about doing before, but we're going to do it really quickly because, you know, if we have that trick, use it. But just in case you didn't, if you're like me and you didn't realize that until it was too late, we can just plug it in. So we get 8 is equal to what was it? 4 squared plus 24. And also, if you realize, if you just plugged in -4 on this equation, it would be, you would still simplify it to, actually, I'll do it right here. 16a. Regardless if it's positive or negative 4, it's just 16a, and that's the only thing that affects it or changes or stays the same. 16, I'm just going to subtract 24 both sides, and we'll get 16. A is 1. Sorry, a is negative 1. Negative 1 is equal to a. And, let's say we plug that in. I'm just going to use g instead of g of x, just for simplify is equal to negative 4 squared. And yeah, I understand that it is a bit poor, the drawing, but it's a bit crude. Plus 24. 4, and if we got that, that would be equal to our answer, A, which is 8. Right. So I did do a bit of extra work, but I did want to show you the mathematical way and the logical way. And that was also a statement. Like, even I mess up occasionally, or more than occasionally. Even the smartest people will mess up occasionally. They will miss the easy solution. So there's always a reason to discuss the traditional way to do a problem rather than just recognizing certain things. Now this one has decimals, problem 11, and decimals are scary because they just look scary. However, it shouldn't be overly complex and it should be rather doable. All right, so let's begin. In the equations above, B and C represent the price per pound in dollars of beef and chicken, respectively. X weeks after July 1st, during last summer, what was the price per pound of beef when it was equal to the price per pound of chicken? Right. So here, just give me a second. I just want to make sure everything's hunky-dory on stream, and everything seems to be A-okay. Perfect. Sorry, I just want to make sure. And we hop back into it, and give me a second. I just want to make sure everything's perfectly fine. So, yeah, I'm going to use this slight break to remind you that if you haven't already, comment something you want me to do, maybe a certain problem, maybe a certain test. I'm open to doing the ACT or even some other college or even higher level exams or even lower level exams, because there's a show called Are You Smarter Than a Fifth Grader, and it's there because adults don't necessarily know all the top fifth graders know. Fifth graders get ingrained in this sort of system that adults forget because they don't need. And sometimes you don't understand that, and it's more than perfectly okay to ask for help, especially for someone who's very much accepting of so. But yeah, I do think we're back, and also if you're on YouTube, comment down below what you don't understand on this that I went through on this test, and I'll try my best to help you in a comment. Or maybe if you just want me to go over something, this is here. I just went on the free official SAT practices and took the first one. This is the first one. There's about like maybe 7 others I can do that are on there, and honestly, there's a bit more if I look deeper. Oh, and speaking of other tests I'm able to do, I'm comfortable doing or trying to do with you, AP tests I will be more than happy to do. In fact, I've been planning to do some. Honestly, I was thinking about maybe speed running an AP test, but that would be fun, not for the viewer. Right. So let's just get back to the problem. But yeah, make sure to voice what you want to be seen, I suppose. Right. So we have these two equations, and so this is the price of beef, and this is the price of chicken, and this is X. And it's asking, really the last line to what it's asking, what was the price per pound of beef when it was equal to the price per pound of chicken? So we can solve for either beef or chicken, but we have to find the intersection point. So actually, this is really easy to do. So basically, we have to find the price of beef or the price of chicken. So what we're going to do is, guess I'll type it out. 1, solve for, equate both sides, both equations, because it's asking when are they equal. 2, solve for x, and 3, plug into either equation. And we can plug into either because we know it's the price per pound of beef when it was equal to the price per pound of chicken. we can plug into either because regardless, the prices are going to be equal. All right, and just something to note, if anything is less than $2.35, we can eliminate it basically. Because we're assuming, and we can do that because we're only assuming like x is 0 or greater. We are not assuming any negative numbers. We're not assuming that they counted the price before July 1st. So if there were any answers, and there's not, so that's actually a good thing. But if there were any answers that were like that, we could eliminate them that were below 235. We could mentally eliminate them. Technically, though, they could still be an answer, but not even the darndest of test makers would do such a heinous thing. Right. Also, something to bring up. Every variable that you're going to solve for that's not necessarily an answer will usually be an integer. In fact, even on the what's it called, the latter part of this non-calculated test, the one where you have to fill in the answers, those are usually going to be integer over integer or just integer point something something. You're rarely ever going to go so incredibly deep into it, and that's a bit lovely. That's something you can take for granted. But without further ado, let's just hop right into it. So we're looking for when b is equal to c. So we could write b is equal to c, which is equal to that, which is equal to that. But what we're going to do is we're not going to write b or c at all in this little stitch. We're going to write equation for b, 2.35. 5 is equal, or sorry, not equal, plus 0.25 x is equal to 1.75, and that was what we drawn. I'll fix that in a second. 75 plus 0.40x. All right, now what I'm going to do is, well, from this point forward, I'm going to multiply both sides by 100 because I'm allowed to do that. And it makes it easier because I don't have to deal with decimals. I can deal with whole numbers, which is I feel more comfortable doing personally. So I'm just going to write times 100 here as a note and start just a bit right. And then after that, what I'm going to, or sorry, not after that, during that, I'm going to subtract 175 from both sides and 0.25x from both sides. I'm going to flip it around just so I get the x on the left side because, again, I feel more comfortable doing that. Right, so we have 15x because I did multiply both sides by 100. So we have 40 minus 25, which is 15x, is equal to, and then on the right side, we have 235 minus 175, which would equal, that's 60 even? Is it 60 even? Yes, 60. And then x is equal to 4. Equal to 4. And I do believe that's the correct value of x. I did kind of breeze through it just a little bit, so I might be a bit off. No, I mean, I'm correct. And I'm going to plug it into the top equation because I like dealing with 0.25 better. And now we're going back to decimals just because I'm going like just because technically it's not mathematically correct. When we did it before, we multiplied both sides by 100, which we're allowed to do mathematically. But for the price of beef and chicken, we'd have to multiply by 100, divide by 100. So we're not going to do that. Instead, we're just going to do b is equal to 2.35. 2.35. Oh, not times, but plus 0.25 times 4, which is equal to 3.35. And that's our answer. Choice D, 3.35. And isn't that lovely? It just works out rather seamlessly. Right. And now we'll move on to question 12. And I'm not sure. I think I might even consider this one of the harder problems. I'm not sure. I might go over that if it shows us what the harder problems are. But yeah, no one. Before I do that, I'll actually see if it shows what problems are hard. Test answer sheet. Oh, there's a test answer sheet. Here, I'll actually pull that up on a separate device. But yeah, I do have the answer explanations, which are also a really good source and whatnot. But yeah, so I'm basically doing that, except I'm doing it without looking at it, I suppose. I'm just looking at the answer choices and solving for them. I'm not looking at the actual solution. Here, I will try my best to see if, oh, worksheets, worksheets, worksheets. Oh, I'm pulling up the math, reading. Unfortunately, no, it does not show which answers are correct and which ones are not. That's really unfortunate. But yeah, we are on question 12. A line in the xy plane passes through the origin and has a slope of 1 over 7. Which of the following points lies on the line? So here, let's make a note of some of the things that we know. Oh, that's my bad. 1, quote unquote, passing through origin. We know, oh, I mistyped 1, but yeah. If it passes through the origin, we do know, oh wait, am I pressing the wrong thing? Oh no, I need to make sure. Yep, everything's on, okay. Man, I'm really messing up here. Sorry, I just thought I accidentally hit one of my hotkeys. All right, so 1, I can't type anything. That's weird. Passing through the origin. B, the intercept is equal to 0. No intercept. Well, there is an intercept, but it's 0. So I should not say no intercept. And 2, if it has a slope of 1 over 7, well, that's just dandy. All right, so let's use common sense for this. We're not going to even write anything out, so I'll just delete this. Why did you save? That's dumb of me. Let me cancel. But yeah, that's something. I will file new, don't save. That was really foolish of me. But yeah, we can just use common sense. So what this is saying, if it has a slope of 1 over 7, actually, you know what? I will write something. Y is equal to 1 over 7x. That's all I'm writing. That's all I'm writing, just to show you. This is the equation that they want you to derive. That's the equation they're giving you. So this is technically a plug and chug, or yeah. But we know the intercept, like when x is 0, y is 0, so a is incorrect. It even says it passes the origin, so you already know a is wrong, regardless. For b, 1 over 7, you might think that's the correct answer, but you are incorrect because the 1 is with the x, and that would, if x is 1, y is actually 1/7, which is incorrect. C, if it's 7/7, it has a slope of 1/7 and it passes the origin, so you know that point's impossible already. But let's just plug it in. Let's say x is 7, that means y is 1, which would mean it would be 7/1. That leaves D is the correct answer, which it is. If you plug in 14 for x, you'll get 14 over 7, which is 2, which is y, and which is the answer. So yeah, that was one of the easier problems, which is really much appreciated. Right? And, oh wait, I can do this. Haha. All right, so that was 12, I believe. Yes. And I'm going to keep this here, even though it's useless. It's just going to be a bit of a hassle to erase. But actually, you know what? I'll just erase it anyway. Hit it with new, hit it with don't save. Right. If x is greater than 3, which of the following is equivalent to that nasty fraction? Right. So this actually, so the reason why they say if x is greater than 3 is because they don't want any jargon in the denominator. They don't want it being such that x is actually, let's see. Oh no, I did that wrong. Never mind. Here. So I think the best thing to do would just be to bang it out. If x is greater than 3, what is this? So one thing I'm going to do first is the infinity test. Technically, this is something I just feel is easy to do. X is equal to infinity. That's the infinity test. So on the let's try it on the original thing. So you have 1 over 1 plus 1 over, yeah, whatever. 1 over infinity, that's basically 0, quote unquote, plus 1 over infinity, which is basically 0, quote unquote. So it's 1 over 0, and 1 over 0 technically isn't an answer, but it's basically infinity, quote unquote. So we want something that approaches infinity as x gets higher. And we can eliminate a because of that. Because a on top, the bottom increases faster than the top does. And we notice that on the top, we can, let's let's just take the highest power of x on each. So let's assume it's 2x over x squared, or basically 2 over x. That's what we basically limit to. Obviously, there's more stuff to it than that, but that's the infinity test I like to do. Granted, it didn't eliminate much time or anything really, but it's really something easy and simple to include. Right. So the first thing I'm going to do is I'm going to leave out the 1 over and just write the denominator first. So 1 over x plus 2 times, so not times, plus 1 over x plus 3. 1 over x plus 3. Now what I'm going to do is I'm going to multiply the left side, or the 1 over x plus 2, by x plus 3, and multiply the right side by 1, sorry, right side, which is 1 over x plus 3, by 1 over, sorry, x plus 2 over x plus 2. And I'm going to simplify it a bit, but that will basically net us to a point where we have x plus 3 plus x plus 2 over x plus 2 times x plus 3. X plus 2 times x plus 3. All right, now that's a good step towards our answer. And actually, it'll probably bring us to our answer quickly. So our answer is actually B. And it makes sense, right? So again, we proved A was wrong, but let's say we didn't. We do know we have to flip this, basically. So we have to throw this to the negative first power, basically, because what's wrong with this is we're trying to find one, like here, instead of that, let's say this is equal to y, and we want 1 over y. So we're going to need to multiply both the top and the bottom by x plus 2 times x plus 3. And honestly, I'm not sure why they include the if x is greater than 3. I'm not sure. Honestly, I'm just not really sure. Granted, I will say it could technically be C. If, you know, if things simplified, it could be C. But here, I'm going to stick with this. So basically, when we have this, we can see a few things. First, on the, we'll flip this. So on the denominator, we have x squared dot, dot, dot. On the bottom, we have just x dot, dot, dot. Granted, you know, there's coefficients and everything, but they don't matter. So that basically eliminates, which simplifies to x dot, 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 which simplifies to x. So the only things that are similar to that are b, where it's x squared over x, for lack of a better term, eliminating all coefficients, all non-highest terms of the denominator and numerator, it's x squared over x, which simplifies to x, and c, which is just x. So it's between b and c. Those are the smart choices. But yeah, we can do 1 over y, so we're just going to flip it, and we're left with, well, x squared plus 5x plus 6 over 2x plus 5. I would write that all out. Well, I would flip it and multiply it, but it's really just going to net us the same thing, so there's not really much merit in me doing so. Right, so I'm just going to delete that and move on. Right, we're in 14 now, and 14, let's see the problem. If 3x minus y is equal to 12, what is the value of 8 to the x divided by 2 to the y? Uh, well, that's certainly interesting. Here, let me just, this one I will say is hard. I believe, yeah, there is in fact an answer, and we will try to do so right now. Right. So, to make it a bit, I guess, easier and whatnot, let's, all right, so we do have an equation. If 3x minus y is equal to 12, what is the value of 8 to the x divided by 2 to the y? And actually, this is much easier than it seems, too. It's a bit complex, but I will say the big thing about this is to note the if 3x minus y is equal to 12. Basically, what this means is we're going to solve for this. Right. So before I write anything down, let's write this. So we have 8, but 8 is equal to, sorry, we have 8x, so 8 to the power of x, but that's equal to 2 to the power of 3 to the power of x, all right, which is equal to 2 to the power of 3x. Because, and by that I mean, yeah, that makes sense, right? Yes. Because, we could simplify it as 2 to the power of x times 2 to the power of x times 2 to the power of x, and we'll get that jazz. Right. And then, so we have that 2 to the 3x over 2y. And considering this, there's the same base, we can say that's equal to 2 to the 3x minus y. 3x minus y. And because that would be equal to 2 to the 12th, because we already have 3x minus y is 12. So 2 to the 12th, which is a, which is our answer. Now I'm actually, what I'm going to do is I'm going to go to the problem and make sure the proof is the same. Because I'm actually not entirely confident on that. I do know the answer is correct, but I want to make sure the proof is the same. I want to make sure I got 2 it the right way. Math test, no calculator, and that was problem 13, 14? Yeah, 14. So the same base, yes? 2 to the 3 for 8 in numerator gives 2 to the 3 to the x, which can be written as that. Yeah, because you can multiply you can multiply powers, I suppose. And I forgot to say that you can multiply powers. But yeah, it is roughly the same. Right, so that was 14, and we can just rid ourselves of that. Don't save. I said don't save. And I'm surprised I didn't have 15 on the same page. Or do they not have? Where's 15? Actually, I'm confused. Yeah, where is 15? Am I blind? Oh, I am blind. It is right here. Right, so let me just pull it up and do it quickly. Right. If a times x plus 2 times b plus x plus 7 is equal to 15x squared plus cx plus 14 for all values of x, and a plus b is equal to 8, what are two possible values for c? All right. So this one is fun. I will say this. This is actually a fun problem to do. So let's make our, I guess, what do we call it? A Punnett square? We have bx plus, and bx and 7. And let's make the square already. Yep, looking like a, well, square, I suppose. With ax plus 2. Ax and 2. So we have the 14. We don't really care about that, actually. We have the abx squared. Abx squared. And we have the 7a, 7ax. And we have the 2bx. Right. We don't actually care about this 14, But we know this, whatever this is, it's equal to this term. So we'll have, so I could write it out as abx squared plus 7ax plus 2bx plus 14 is equal to 15x squared plus cx plus 14. However, that takes a lot of space to write, and I can't write that small in this. So what I'm going to do instead is what the next step would be. So I'm going to skip a step lightly, skip the writing out step, and instead write the powers of x. So yeah, I'm going to actually physically write down powers of x. Powers of x. I'm going to group by powers of x. So yeah, group by. Group by powers of x. Right, so we have 15x squared. So, sorry, I'm going to write the x squared. These are the coefficients for x squared, and they must be equal. And I'm going to use a little colon to signify it. Yeah, but a times b is equal to 15. Because a times b times x squared is equal to 15x squared. There's no other x squared on this, well, math. And for c, well, let's see, I suppose. What are the two possible values for c? All right. Oh, and here, actually, sorry, I did I'll make a mistake, just a little bit. I was gonna hop ahead, actually, no, I will still hop ahead and do everything. So for x, and we're not gonna do x to the 0th power, just 1, because that's 14 is equal to 14. That doesn't provide us with any useful information. So you got 7a plus 2b, right? Yep. 2b is equal to c. Cool. Really nice. Now, let me just say something right before that. Choice A is the really trick answer because it's not correct. Choice A is, in fact, incorrect, and we'll provide in a second. However, just for statement, what you're probably going to end up getting is A plus B, sorry, A is 3 and B is 5, or some other alteration of that. But that's not what we're looking for. We're looking for values of C. And I say A is 3 and B is 5 because, here, a factor tree for 15 shows 5 and 3 as the possible variables, right? Those are the two prime numbers that would multiplied make 15. So either A is 15 or B is 15. Oh, all right, so let's say in terms of, so we can prove, for assuming integers, which isn't necessarily the case, but yeah, assuming integers, because we know that test makers aren't, like, they're evil in sensible ways. They're not chaotic evil, they're lawful evil. A comma B, I did draw A poorly again, the way I'm used to, so I do apologize, but A comma B, they're either 3 comma 5, because those are the only two prime factors of 15, or 5 comma 3. So now we plug it in. So 7 times 3 plus 2 times 5, 2 times 5 is equal to 21 plus 10, which is equal to 31, which is equal to C. And that gets us choice D, which is in fact the correct answer. And we would probably check it again by putting in the other values. So 7 times 5 plus 6 times 3, sorry, 2 times 3, which is 6, is equal to 41. And that is in fact true. 41, which equals C. And that is our answer. This is definitely one of the harder problems on the test, I feel. I feel like choice A is really a good trick. It's a really good trick. And yeah, the way they keep you in vague by saying there's two possible values for C and not telling you why there's two possible values for C, because A and B could be alternate. However, I will say this. Technically speaking, with the diction that they use in this problem, the way that they word it, This problem is incorrect in its very statement, simply because of the fact that we're assuming that a and b are integers, which we are not inherently given, unless it says it right at the beginning, which I don't recall if it does. I could be wrong. Because, b could be, oh wait, I forgot 15 and 1. Oh, man, I did forget 15 and 1. 15 and 1 are some solutions as well. And 7 times 15, oh my. Sorry, this solution, I was going to say, in technicality, this solution is flawed. However, in reality, this solution is flawed regardless. Furthermore, we're neglecting -5 and -3 and -15 and -1. And those are all the possible integer values. So what I'm not trying to say is it's not two possible solutions, two possible values for C. That's blatantly incorrect. That is hideous. That is awful. Oh my, that's atrocious. Because in addition to 31 and 41, you can apply that A is 15 and B is 1, and you'll get roughly, well, 7 times 15, that's 70 plus 35, or 105 plus 2, which would be 107, and we can try the other thing. 2 times 15 is 30 plus 7, 37. So you're neglecting 107 as a solution. You're neglecting, what is it? What did I say? 37? Yeah. 37 as a solution. You're forgetting -31, -41, -107, and -37. CollegeBoard, this is atrocious. This is truly hideous. I am honestly displeased. I know you're evil and all. You're one of the most evil corporations in existence. However, this is atrocious. This should not stand. You expect students to get this right when you are inherently wrong in this. You do have an answer, but you're saying, what are the two possible values for C? There are more than two possible values for C based on an equation. There's infinite many, but even if you're only including integers, I apologize, there's 8. And even if you're only including positive integers, there's 4. Regardless, there is no case that it's possible to deduce where it is in fact possible for C to only be two separate things based on the information given. Wow, my throat is getting really hoarse from screaming at CollegeBoard, but yeah. CollegeBoard needs to do better. This is disgusting. I might actually write a formal complaint about this. But yeah, I didn't. Oh, did I close it? Close it? No, I just minimized it. All right, right. Now we're on to the fun section. But yeah, I'm totally appalled. I'm flabbergasted and appalled. But yeah, there's no reason to indicate that it should solely be integers. There is truly an infinite amount of solutions, and I am. Oh, wait, never mind. I'm a dummy. I'm dumb. I do apologize. I forgot the a plus b is equal to 8. Yeah, that was a bit foolish of me. It's my bad. Yep, I do apologize for that, because that means a is equal to 8 minus b, or sorry, I'm messing up, and we multiply that by b, so we get 8b plus a negative b squared minus 15 is equal to 0. And technically, this is the smarter way to approach a problem like this. But yeah. And we should know that it doesn't seem to be a perfect square. So there is technically two values in which this is, I guess, true. Two factors of 15 that subtract to give me, oh, nope, I did it wrong. B's, considering we have to, I guess, what's the word? We have to divide by a negative with all terms. Plus 15 is, okay, never mind, it is right. B is equal to 5, and B is equal to 3. Yep, I do apologize for that. My random outburst. I neglected a key, crucial part of the problem, and yeah, with math we proved that that is the only solution. I apologize for that tirade. Right. For questions 16 to 20, solve the problem and enter your answer in the grid as described below on the answer sheet. Although not required, it is suggested that you write your answer in the boxes at the top of the columns to help you fill in the circles accurately. You will receive credit only if the circles are filled in correctly. Mark no more than one circle in any column. No question has a negative answer. Some problems may have more than one correct answer. In such cases, grid only one answer. Mixed numbers such as 3, 1 half must be gridded as 3.5 or 7 halves. If 3, 1 over 2 is entered, it will be interpreted as 31 over 2, not 3 and 1 half. If you obtain a decimal answer with more digits than the grid can accommodate, it may be either rounded or truncated, but it must fit the figure end, entire figure grid. Right. Yep, all that jargon, whatnot. And 16. Ooh, T, I like T. T is a good variable. Actually, I'm going to move over a bit more. Just scooch it in the frame. Right. Let me just see. Yep. So if T is greater than 0 and T minus 4 is 0, what is the value of T? Well, first we'll do T squared is equal to 4. Or actually, no, we're not even going to do that. We'll use difference of two perfect squares. T minus 2 and T plus 2. Granted, we could just literally do add 4 to both sides, take the square root, and only the positive root of that, in which case T would be equal to 2, which is the correct answer. But in this case, we're going to do just difference of two perfect squares, because difference of two perfect squares is very useful. Equals 0. So we get T is equal to -2, which we can't use, but we can use 2, and that's our answer. T is equal to 2. Yep, that was really quick and easy. So now we're on to 17. Ooh, I think I've done this, I feel. Yeah, I think I had this problem in one of my tests in high school, or similar problem, not this one exactly. All right, one thing to note before I even read this problem is that these are similar triangles. Angles DBC and ABE are all equal. Sorry, angles DBC and ABE are equal. Because, you know, the theorem where if you see one on one side, blah, blah, blah. So yeah, if you rotate triangle BDC around, 180 degrees along the point B, you will get a triangle with the same, with they're similar triangles. So you get just literally a smaller triangle, right? So that's good to note, but yeah, we're not, let's see if we're going to use it. A summer camp counselor wants to find a length x in feet across the lake as is represented in such light. So we're trying to find x across the lake. Nice. Lengths represented by AB, EB, BD, and CD on the sketch are determined to be 1800, 1400, 700, and 800 feet respectively. Segments AC and DE intersect B at the same measure. What is the segments AC and DE intersect at B? AC, yep, they intersect. And angle EEB and CDB, the same measure. What is the value of x? Right. I'm saying because I'm gonna have to copy. I'm gonna have to really redraw this image, which I don't want to do. We know it's similar. What is the value of x? So x. So AE. We're trying to find AE. That's basically it. So the line AE is equal to some value, which we'll call y, times DC, because they're similar triangles, as we stated earlier. So we know what DC is, right? CD is 800, so y times 800. All right, that's cool, right? I think I'm not going in the right way. Yeah, and here, what's the first thing we see? AB, and do we see, considering if we rotate 180 degrees, the component angle, the complementary line would be BC. We have AB and BC. We have AB, EB, and BD and CD. Oh, so we can use BD and EB, right? So EB is equal to YBD, right? Because again, we have to rotate it 180 degrees. And I would draw it, but I can't draw it on this, so I really do apologize. But if we rotate it 180 degrees, we'll see it's literally just a smaller triangle of the same angle measurements, and which we can prove because, I can draw this. And basically, this is always going to be equal to this. Two intersecting lines will always have opposite angles on each side. Equal angles on each side through that. And again, these top angles will always also be the same, but that's not what we're gonna really pay attention to. But yeah, paying attention to this, and that proves they're similar because if two angles are the same in a triangle, it's three same angles, three equal angles, equal angles. Oh, but why did I not type that? That's easy. We have three equal angles, and the third one is equal. EAB and BCD are equal because the other two angles are equal, and triangle theorem. Sum of all sides of a triangle must be equal to 180 degrees. You do the math, blah blah blah, all that jargon. But yeah, they're similar triangles. Is what I'm trying to say. So back to the EB and BC. EB is the second thing, which is 1400, and what is BC? 700. Yep. BD. Wait, did I say BC? I meant BD. It's my bad. And 700. I drew 1400 very poorly, but we know y is equal to 2, which means x is equal to 2 times 800 because, AE, where x is equal to 2 times 800 or 1600, and that's our answer. 1600 is our answer. So let me just draw it as quickly as I can because we're not staying on this problem for long because we're done. 1600 is our answer. We did that well. But yeah, the key to this problem is noticing that it is in fact a similar triangle. Right, that's 17, 19, or we didn't do 18 yet. 18, right. According to the system of equations above, what is the value of x? Again, we could use graphing, we can't use graphing, but we can use substitution or elimination. I'm going to do substitution for this. Not substitution, elimination. Wait, elimination. I confused the two already. Yeah, elimination. Right, so I'm going to multiply the top equation by 2. Negative 2. X plus y is equal to negative 9. And x plus 2y is equal to negative 5. Plus 2y is equal to negative 25. And I'll fix the x because that really looks mighty scuffed. And then doing our math, we add both together, blah, blah, blah. We have negative x is equal to, 18 to 25. Why did I say 26? That should be negative 7. So x is equal to 7, and that's our answer. 7 is, in fact, our answer. That is the correct answer as well. Right. And this one was actually pretty easy, just using elimination. Granted, we could have used substitution. We could have got y in terms of x. We could have, using the first equation, we could have got y is equal to negative 9 minus x and plug that in. However, this seemed easier to me. Granted, if you use the other one, that's fine. I would go over it. However, considering I just went over it earlier, I don't feel a necessary need unless someone asked me to, in which case, yeah, I'd be more than happy to. But yeah, same method as before. I just described it to you, and you can do it on your phone, I suppose, if you feel confident doing it more so that way. But yeah, you'll get 7. In a right triangle, one angle measures x where sine of x equals 4/5. What is cosine of 90 minus x? Cosine of 90 minus x. Shoot, I feel like there's some sort of easy trick that would make it easier, but honestly, I forgot. I'm not a genius at these sort of things. I haven't taken the SATs in a while, which is a good thing because I hate the test. But yeah, so right triangle. What is yeah? I I do believe that cosine of x plus a 90 is equal to sine of x. Uh, so what we could do is we could try to solve. Yeah, I'm assuming it's the same thing. I'm assuming it's just 4/5. I believe that's actually the answer. Yeah, the answer is 4/5. In fact, I'm assuming it's the same thing. I'm assuming it's just that neat little trick where it's, but the cosine being it being cosine 90 minus x is confusing me. I do believe that cosine of x is equal to cosine of negative x. I do believe that is a true statement. Yes, it is true. Yeah, it is true. So we can factor out a negative from the x 90, so we get cosine of x minus 90, and that should be correct, right? And I guess always on these problems, it's pretty cool to draw a unit circle. I mean, granted, you don't really need it. So you want sine of x to be 4/5. So let's say 4/5 is right around here. So sine of x, oh, right at this angle. But you want cosine of 90 minus x. So basically, you want the cosine of right here, because this is 90 minus x next to this big angle. So you're left with this, and it should be the same value, considering cosine is this and sine is this. Sine is the height, cosine is the width or length. So yeah, it is worth it. I believe they'll describe it better though. So let's go over and go to 19. The correct answer is 4/5 or 0.8 by the complementary angle relationship for sine and cosine. Sine of x is equal to cosine of 90 minus x. Therefore, cosine of 90 degrees minus x is equal to 4/5. Either fraction, 4/5 are just equivalent. Alternatively, apologies. Alternatively, one could, in fact, construct a right triangle that has an angle measure of x such that sine of x is equal to 4/5. Shown as the figure below, where sine of x is equal to the ratio of the lengths of the opposite sides angle, hypotenuse since two angles. All right, sorry, I'm just skimming it, not reading it aloud. Shown as where sine of x is equal to the ratio of the length of the side of the opposite angle, measuring x to the length of the hypotenuse, or 4/5 in this case. Since two of the angles in the triangle measure x and 90, so yeah, basically it's just a math rule, which you can prove with triangles and whatnot. I tried to prove it with unit circle, which I feel I did decently with. Not too well, but yeah. But it should be the same because I guess sort of mirrored around that. But yeah. If you don't know the rule, I guess you could try to prove it as best as you can. And now we're on to 20. If a is equal to 5 root 2 and 2a is equal to root 2x, what is the value of x? What? Are you, is that it really? All right, well, let's just plug it in. So instead of a on the right side, we're just going to use 2a. So we're going to use 10 root 2, because, 5 times 2, this is 2a, is equal to root 2x. And, for simpler sake, I'm going to just rewrite this as root x times root 2. Root x times root 2. And I'm going to cancel this out with this. root x is equal to 10, and x is equal to 100, and that's our answer. Equal to 10, which is equal to 100. Oh, sorry, that's not equal to 100. X is equal to 100. Didn't show me squaring it, but yeah, 100 is the answer. And yeah, that was underwhelming. That was just simple. So yeah, that's that, I suppose. And now this is the time where we, I guess, take a bit of. Whoa. That's my bad. I zoomed in way too much. All right. Math test. Calculator. For questions 1 through 30, solve each problem. Choose the best answer from the choices provided and fill in the corresponding circle on your answer sheet. For questions 31 to 38, solve the problem and enter your answer in the grid on the answer sheet. Please refer to the directions before question 31 on how to enter your answers in the grid. You may use any available space in your text booklet for scratch work. The use of a calculator is permitted, in which case, do use a calculator. Use a calculator, use a calculator. All variables and expressions used represent real numbers unless otherwise indicated, and all this other jargon that we just read earlier gives us this nice sheet, same as before. And yeah, I guess we're ready to start. But before we do, I'm going to take a quick little break, and just to again freshen up and everything. And granted, you would be given, I forget how long of a break, but a decently long break. So yeah, please get water, get whatever you want, and get ready. Yeah.